Hello. Right, this one is called Venn diagrams. Now, this is in two parts. So let's crack on with the first part. So a Venn diagram looks like this. Well, it actually looks a bit straighter than that. That's a bit awful. Let's come round. So we have this and we have this. Okay. And we'll call this T and C. So this funny Greek letter, chi or something like this means everything. And in this case, everything equals 20 because we've asked 20 people whether they like tea or whether they like coffee. And we'll say that 12 people drink tea only, 5 people drink coffee only, 1 person drinks both, and that makes 18, and therefore 2 people don't like either. So you get a probability question on this. What's the probability of someone chosen at random? And these are the words that point you random. These are the words that point you to everybody. Yeah, someone out of everybody likes tea. Someone chosen at random likes tea. Okay, so how many people like tea? 12, 13 people out of a total of 20. And what's the probability of a tea drinker who also likes coffee? Right, so tea drinkers. How many tea drinkers? There are 13 tea drinkers, and one of them likes coffee as well. So this would be 1 out of 13. Okay, let's try and get these a bit squarer. So I suppose I could do this, couldn't I? Let's have make it a bit nicer, yeah. Okay, so here we've got the data set, or everybody is 30 people asked, and we've got dog, and we've got cat, and you've given some information. 21 have a dog, 16 have a cat, and 8 have a dog but no cat. Okay, so first task is to fill this in. So 8 have a dog but no cat, so 8 go in there. So how many dogs? 21 dogs. So this middle bit must be 21 minus 8 equals 13. So 13 of the dog owners must also have a cat. Now 16 have a cat altogether. So 16 minus 13 equals 3. So 3 people have cats alone. Now we've got 13, 16, 24. So that means 6 people don't have anything. Oh, right. Another one. Well, this is from today's lesson that I do apologise everybody, I got some little bits wrong earlier on, but this hopefully will put it right. And so we've got 50 people altogether, and we've got 2 circles. These are good circles, aren't they? 2 circles, and we've got T and say SM. So what's T and SM mean? T equals text, and SM equals social media. Right, let's have some information about this. So this one's already filled in for us, yeah? 20, 17, 8, and 5. So it's just a probability then. Yeah, a probability chosen at random. That means everybody. Uses text. So everybody is 50, and texts are this 20 plus the 17, which is 37. Okay, that's that filled in. That's nice and easy, that one, wasn't it? So let's have a look at the next one. Okay, so let's go down to the next one. Now, the data set here is equal to the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And let's put the 2 circles in there. And S and E. So S equals a square number, and E equals an even number. So first job, let's have a look at this, and then we've got a probability question. The probability of S and this symbol there and E. Now this N is the intersection of S and E, which is this bit in the middle. Yeah. So let's put the numbers 1. 1's a square number. 2 is an even number but not square. 3 is an odd number, which must go down there. 4 is an even number and it's a square. 5 is an odd number. 6 is an even number. 7 is an odd number. 8 is an even number. 9 is a square number but not even, so it goes there. 10 is an even number. 11 is an odd number, and 12 is an even number. So the probability of the intersection between the squares and evens is this bit in the middle, which is 4. It's the number 4, but it's 1 out of 12. Just 1. Easy mistake. Plenty of easy mistakes to make on this one. Right, let's come through. Here's another one. We've got a circle and a circle, and this one's F and G, and the data set is 36 people, and F means French, and G means German, and this is the subject studied at a particular class or college. So we've got 20 French students and 9 German students, and 3 do both. So let's fill this in. So 3 do both, and we got 9 German ones and 3 we've accounted for, so there must be 6 there. 20 French, we know about 3, so there must be 17 there, and that makes 26. So 36 altogether, so there's 10 over there. So what's the probability of F, U, G? Now this is the union, which means and both of them. Yeah. So all the union, you can do it this way. All the F's and all the G's. Yeah. So it's everybody, not that bit in the middle. It's everybody. So that's 26. French or German. So that's 26 out of, what's it, 36. So what's the probability of chosen at random? That means everybody. doesn't study French or German. So, doesn't study French or German. Right. The people that don't study French or German are these 10 people, aren't they? The 10 round the outside, out of 36. So when you don't have something, let's go round here. So when you don't do something, or doesn't, if it's there, for example, there, you don't do A, it's everything apart from A. So it would be all the people in this bit, everybody that's not in A, yeah? So that bit's in A, that bit's in A. So if you add all the people here, you'd have, say, 2 and 12. So the things that don't do A are 14, yeah, out of however many there are altogether. That's don't do. Right, okay, next up. These can get quite complicated, as we will see. Here's another one. So we've got 2 circles. I don't know how difficult this one is. Yeah, 2 circles, and we've got A and G. And what's the data set? 295, and A is equal to art. G is equal to geography. And this is pre-populated with numbers 25, 14, 29, and 227. So, right, chosen at random. Everybody takes art. So there are 39 out of a total of 295. And the probability, go down a tiny bit, the probability that an art student also takes geography, tells the condition here, we're only looking at the art students, which are these here, which is 29 and 14 is 30 and 43, so there's 40 art student, 29, that's 30, 43 art students, and the people that also take geography are the 14 there, 14 out of 43. Geography student takes art. An art student, oh no, I've got that ran the wrong way. I thought the numbers were a bit bonkers. Let's have a look. An art student, that's these, it's 39 art students. And there's 14 art students also take geography, so that's ran the right way. Now the second part of this is learning about the symbols and the signs and what area they represent. So let's try and do a load of shapes, yeah. So 1, 2, 3, I don't know how many we're going to do, so let's try 4, 5, let's do 6, because it's 2 rows of 3, isn't it? So that might work, yeah. Oops, come down a bit. So they're all perfectly aligned and all in the same shape. So we're going to have some little circles in here. AB, AB, I'm sure others are a bit more slick than this, but I not get any prizes for video production, but doesn't matter, it's the maths that count. Okay, so what we're going to do is shade in all of A. Shade in everything that's A. Nice and straightforward. There. Now, I guess we're shading everything that's in B. So we know what areas we're looking at, yeah? And now we'll shade in everything that is not in A. Not in A. So everything that's not in A. And this will include this bit here. Okay, everything that is not in A. And the next one is going to be everything that is not in B. So everything outside of the circle of B is everything that is not in B. I mean, you can save time here and do these with diagonal lines, which I will be doing in a second when I'm using two criteria. Something that's in A and not in B, and something that's not in A and that sort of thing, yeah. So that's right. So there's the four basic ones. It's just a single, yeah, everything that's not in A. Everything that's in A, not in A, in B, not in B. Now, let's have a look at this one. Okay, now this one is going to be A or B. Now this is an N, and I'm going to call this the intersection, because there is an N in the word intersection. That reminds me it's this. So for this, I'm going to use a hash type pattern. Yeah. So I'm going to do the A. Everything that's in A is this. And then I'm going to chop the other way. Everything that's in B is this way. And where they cross, where you get the crisscross pattern, that is what we call the intersection of A and B. So that is everything that is in A or in B. The intersection of A and B. Now, the other way round is this sign, yeah? And this is called the union. Now, the union of A and B. So, again, we don't do the crisscross for the unions, we just do this. So, everything is in A is this way, sometimes called the cup, I think, or cap. And everything that's in B. So now, that area is this one. So it's the whole of A and the whole of B. And this takes a long time to get this to sink in. Union and intersection. Now, call that union because there is a Y in there. Call that intersection because there is an N in there, and that's a shape. Right. So we can take this a little further and some more, I suppose. We can have, oh, don't want that, do we? Goodness me, shapes. Right, so we'll do 4 more. I'm sure there's a way to copy this, copy the shapes. Yeah, we just do right click and copy them. Everything would be the same size, but never mind. We're doing it this way. Yeah. So we've got 4 more. So let's do the perfect. A, B, A, B, A, B, A, B. Right, this one, everything that is not in A, intersection B. Right, intersection. We do this. Okay, not in A. So this is not in A. All this around the outside, and including that bit. So there's everything that's not in A. Now we want everything that's in B. And we go the other way. And where we get the crisscross pattern, that is the area that satisfies not in A or in B. There, that one. Okay, the next one is going to be not in A, union B. Right, so now this one, we just do the single do. So when you got the union, you do the single lines. When you've got the intersection, you do the crisscross. Union, not in A. Not in A. And everything in B. So everything in B includes that little bit there. So now that area is the one that's represented here. A bit garish, these colours, aren't they? But we get there, don't we? We get there in the end. And also this bit up here. There. And including that little bit in the middle. Okay, so that's the there. So now we'll do the final one, which can be written as this: A intersection B, a knot. And this one is A union of B and knot. So intersections, we do the crisscross, and unions we just do this. So not in A, this could be written as not A, not B. It's the same thing, yeah. So not in A is all of this. Whew. And not in B is all of this. Right, and colour in all the crisscrossy bits, And this is more than likely just a multiple choice question where you're matching up one of the criteria with the picture of the shaded regions. And I don't know, there's something strange about this. Is that this is one of the very few topics which is so easy to forget. Okay, any more bits? Yeah, there's a bit there. That's that one. Yeah, so when you get the crisscross, that's sort of a blank bit in the middle that didn't even get a look in. Right, okay, this one. So not in A again. And this time we just do the straightforward ones, single lines, and not in B. It's going to be that, including that. So all we've got left, not in A, not in B, is the whole thing, isn't it? The whole thing, not in A and not in B. So it's everything, everything. The union of not in A and not in B is everything apart from that tiny bit in the middle, yeah? Which is the intersection of A and B. So you'll have some little background music to play whilst I'm filling these in, yeah? But there you go, that's Venn diagrams identifying regions. Yeah. Okay, alright, we'll have that one. So that's enough for that. Union and intersection, don't forget.